G'day everybody and welcome back to my channel. Okay, so I've got a few things to go over here. The plot thickens. Not in a bad way, nothing bad's happened, it's all good. I just found something really interesting. Just to show you guys, so far these are all the parts that I've removed out of the thing. But I just want to point something out. I just took out these two 560 ohm resistors. And the reason I took them out is because, and you can go back in other videos and have a look, they were sitting here and here. And if you have a look, one end goes to something that doesn't connect to anything. I've got solder bridging that, that's not good. I always clean all my boards up afterwards anyway, so it's not a problem. But anyway, one end goes to a blank connection that doesn't go to anything else, and the other end goes to a blank connection that doesn't go to anything else. Now, it was definitely populated at one time, I'd say, because it sort of looks like, well, actually, I don't know. See, the thing is, hold on a minute. Yeah, so I think there used to be a resistor and a capacitor in series, and then that went, see there's two different footprints, so maybe there was another capacitor here, so maybe they were two resistors, I don't know, and then maybe you could have an axial or a like an axial or a stand-up style capacitor. But what it does is it goes from the non-inverting input, the inverting input, I always get them muddled up which one's to the left. Anyway, one of the op-amp inputs, it goes from that to the end of the current shunt resistor. Now, so all it can possibly be doing is some sort of compensation. But the thing is, the compensation was already done with the external compensation cap for the op-amp, and now I've got one that's internally compensated. I don't need that cap, and the input's already compensated with this. So maybe there was, I don't know, a resistor network or two resistors there, for example. I don't know why there would be two. I just can't think of what the third component could have been. And there's these holes here too, like, I don't know, it's a bit odd. There's these three little holes up here. I don't know, just makes me wonder. But anyway, yeah, so I pulled them out because they're not connecting to anything. Get down, you're not allowed up here. Man, sit on me, get out. Yeah, so I pulled them out because they weren't connected to anything, and it looks to me like all it could have possibly gone to is just another RC filter. But then there's an extra spot in series with the RC filter that looks like you'd put another capacitor. I don't understand why you'd have, like, you know, an electrolytic capacitor in series with a resistor and then say a ceramic capacitor or polystyrene capacitor or whatever, you know, it just doesn't make sense. So maybe there was a diode there. I don't know. Anyway, I do know one thing. It's definitely not going to be necessary for this, for the op amps that I'm using. As for compensation, on the op amp that's monitoring the current, there are 22 picofarad polystyrene caps. Oh, sorry guys, these cats are... Get out! Out! Get out! Out! Far out! Sorry. Man, could you imagine having cats go through your electronics lab? I don't think I need to say more. Just totally lost my train of thought. Okay. So I was having a look at all the other polystyrene caps that I took out of this, the compensation caps, and they were all 120 picofarads except for 2 of them, which was 68. That's actually roughly the value that I was going to put in between the 2 pins on the one for voltage. What else did I want to say? There was something else I remembered. It'll come to me. I don't want to waste everyone's time. So let's get to work. Components. So for the OR gates, UF4AA7s. 75 nanosecond switching time. That's fast enough. You know, I've got SF37s and SF28s and stuff like that. Like 25, 35 nanosecond switching time, I think. 75 nanoseconds is more than quick enough for this circuit. So UF4AA7s will do the trick nicely. The current shunts, I decided I'm going to use these. They will go in sideways or like stood up a little bit, but they'll fit in there. And because this is the top board, it doesn't matter if they stand up a bit, so I'll probably just stand them up a bit. But that will mean that they'll be able to dissipate even more heat better and run at a lower temperature, and they'll also heat up slower, so it'll maintain a more constant current level of accuracy on the constant current, and not only that, the drift will be slower, not so sudden. So that's especially handy if you're working on something that you just need to power up for a couple of minutes or a minute or 30 seconds. Like, it won't even warm up to the point it starts to drift in that time, you know. Anyway, so there's 2 advantages there. These resistors here, geez, I've got that many things I'm doing at once, I've forgotten what they're for myself. 5.6 ohm resistors I'm going to put on the base pins of the outputs, series pass elements. There are no base resistors on them. I guess they just used matched transistors, I'm assuming, but you know, like, who knows. And also over time they can drift, and also they mount it on a heatsink where the one's on top of the other, so one's going to be hotter than the other. So yeah, and they've only got 10k base to emitter resistors, so it's not like the base to emitter resistor is going to do anything in terms of thermal runaway. I don't see how 10k would anyway. So I'm just going to pause the video and take a couple more measurements before I waste your time just staring at a board. Okay, well, that's interesting. I don't know where I got 10k from, but I just checked the value of the emitter to base resistors, and there's 2 20 ohm resistors in series, like one from each emitter tied together, and then the center point going back to the base. So actually they've dealt with thermal runaway. They've actually, I guess the emitter resistors are fairly high. They were 0.6 ohm before, they're 0.47 now. That's still pretty high. I might not have to worry about base resistors. I might actually still put something in there, but I think I might, in view of what I've just seen, I think I might go with a lower resistance. So let me just go see what I got on hand. I'll be back in a sec. Alright, I've just found exactly what I was looking for. I didn't know if I had any, that's why I didn't say anything, but I was thinking less than 4.7, less than 3.3, standard values. 2.2 ohm. That's perfect. So I'm going to add 2.2 ohms to the base of each transistor. The drivers, I'm going to leave them. The reason I'm going to leave them is because, well, they've got a fairly lower gain. And although they are then therefore using bigger transistors to drive them and bigger transistors to drive that, which is all taking more current, having less gain is obviously, in my mind, going to make it less susceptible to noise and stuff like that. I'll leave it like that for now. Yeah, so also one other thing I noticed I want to point out is the BC107s. In my last video, I deleted the comment because it's wrong what I said. I said I wasn't going to swap them because they're buffering this reference. They're not buffering this reference. I don't know why I thought they were. I was just looking at the board funny. This reference is going to this op amp with a resistor network, and it's for the panel meters. All these transistors are the driver stage for, when I say driver, I mean like the comparator driver, your classical driver stage where you have, you know, a transistor that's biased on by a resistor and then another transistor that pulls its base voltage down. You know, there's that arrangement. Yeah, anyway, that's what all those transistors are doing. And the rest are just Darlington to drive the output. So I'm going to leave all the transistors as they are at the moment, but in the future, if I do decide to change these, I'm going to change all of them. So I'll find better transistors for every single one, all four on each side. But for now, it's just going to stay how it is. I probably will end up keeping it like that forever and never ever actually changing it. So yeah. Anyway, enough talking. I might as well get on with work whilst I'm talking, because there's not really any point in just sitting here talking and then still having to do all the work, is there? So what I've got here is some 1% 4.7k resistors, exactly 8 of them, because someone's put 5% resistors on the inputs to the op amps. Now, some of them probably don't have any load on them because they're going to op amp inputs, but it looks like they get tied in with each other and in with voltage dividers and stuff, depending on whether it's in auto tracking or dual or single mode and stuff like that. So there potentially is a bit of load across them. So I mean, look, you can tell that they've been replaced, and I'd say they would have all been these 1% or 2%, whatever they are, tolerance resistors. So I'm going in with 1%. Like I said, UF400 for the OR gates. I'm going to put these 68 picofarad capacitors that were acting as compensation capacitors on, I can't remember which op amps, but I'm going to put them. I'll show you where I'm going to put them, and I'll do it now. Or do I have to clean up the holes? No, that one's open. That one's going there. No, you can't come in here. Now they're scratching at the door. So that's a 68 picofarad, and the ones on the current section op amp is 22, I believe. And the reason I decided to just reuse these 68s is because I wanted something that was a little bit bigger than... I can't concentrate. Can you stop? Stop! I can't concentrate. I know I have bloody ADHD and Asperger's syndrome and all that, but how can anyone concentrate like this? Piss off! Hey, no, enough. Go. Don't come in here. Oh, you're gonna be shitting me. Now it's jumped up on my chair. Leave me alone. I need to work. Ah, man. You've got to be fucking kidding me. Dude, you're cute, but come on. I am working. Yeah, I can't concentrate. I keep losing my train of thought. This is really shitting me. I don't even remember what I was just saying. I can't even fucking remember where the bloody capacitor was I was soldering. Oh, I soldered it. Right, so, that's what I was explaining. How I came, oh my god. Get out of there. Get out of there. No. Right, that's it. Get out of here. Don't scratch at the door again. Just go. Go, please. I've got work to do. Oh, God. So I came to the conclusion I wanted to go about 4 times bigger capacitance value, but these were lying around. It's about 3 times, so good enough. Simply just because there's going to be slightly higher voltage and current spikes and more noise on the input to this op amp. And the reason I say that is just from tracing out the circuitry. Basically, you see the current op amp, it's looking across the current sensing op amp, it's looking across a 1 ohm resistor, which is then divided down with resistors. So there's not much getting into the inputs of it. Common mode wise there could be, but in between the input pins, not much. The voltage detection op amp, that's a different story. So to filter it, it's going to need a slightly higher value. Now, like I said, I want to keep this thing as fast as I can keep it. So, you know, I'll just put this in for now, and we'll do tests and see if it's, you know, enough to compensate it or not. And if it's not, we'll add more. If it's good, we'll leave it, you know. I just put that in the wrong side, didn't I? You're kidding me. Oh no. Where is it? Wow, I feel like I'm losing my mind. Oh, there it is. I swear I could just not see that pin. Either of them. Anyways, so that's that. There was no capacity installed there. There was a few parts missing down the bottom there. Like I said, that 560 ohm resistor on each side was missing another at least 2 components that were connected with it, plus the compensation capacitor for the voltage detection op amps were missing. So whoever's done work on this has done silly things with it. I don't know why, but I'm here to correct all that and give it many, many, many years of use. And I'm not just adding the base resistors just to help balance out current either. It's also going to help add a bit of a damping factor to the transistors, which is always good in something like a power supply or an audio amplifier. Or, yeah. Alright. I'm not gonna bother marking. Oh, you know what? I'll do it for in future just in case one day I have to do some work on it and change parts and I rip everything out hastily in a hurry and forget to mark it. There you go, it's already marked for in the future. But at the moment it's in my memory, like the diodes point outways, so I don't have to worry too much about that. Now I know what you're all wondering, because from the last video, it's funny I say the last video because as we speak right now it's actually being spliced together and it's not even uploaded yet. But in the last video we've discovered that there's a problem with the current set potentiometer, and well, cut a long story short, it looks like I'm going to be able to use 5k pots quite easily, and it actually almost seems hilarious that they put 500 ohm pots in there. I'm starting to wonder if, again, they didn't put 500 ohm pots in there, but whoever's been doing all these weird repairs on this thing over the years, removing components and stuff like that, yeah, I think it might have something to do with them. Anyway. Oh, that's way too big. What am I doing? I was looking at the wrong holes and I made my diode up way too big. And by the way, for anyone that's wondering, all the components I'm putting into this are legitimate components. And none of them are like, you know, Amazon kit components or anything like that. These are Texas Instruments op amps, these diodes. I don't know what brand they are, but they came from Jaycar, so they're not. They're probably some. Oh, there you go, on semiconductor. So everything that's going into this is of good quality. Just out of curiosity, what channels do you guys all watch? I like to watch Diode Gone Wild or Electro Boom. He's got a couple of channels. Dave from EV Blog, Big Clive. I'm just trying to think. Mr. Carlson's Lab, Mendit Mark, Curious Mark. That's some of my favourite content creators. WAE2W, I think it is. Who else? My mind's going blank. I know that I've got way more favourites than that, but I just can't think of them right now. yeah, I'd be interested to know what sort of content you guys will like to watch. Just out of curiosity. Is it the same channels I watch, or is it completely different channels, or are some the same and some different? I just wonder. Basically what I'm getting at is, what sort of electronics do you all like to watch? Are you more into, like Ian Scott Johnston and The Signal Path? There's another one of my favourites. People who do more complicated sort of work. Or more Big Clive, meaty sort of stuff. Not that Meaty doesn't know his stuff, but, he doesn't, you don't see him making videos sort of like this, for example, like fine engineering level stuff. That's what interests me. I like watching people that do this level of work, at least. Like people that don't have a problem tearing something completely apart, completely rebuilding it, modifying it, doing whatever, and, not being worried that they're going to screw it up. I still like to watch, the smaller channels, not smaller channels, less, I wouldn't say, less experienced. I just don't want to be slack to people. I mean, I know Big Clive can build all sorts of things, lighting controls and stuff, so he's obviously got good electronics knowledge. But I just personally find his content's good for a bit of a laugh, but it's not, for me, it's not educational. So I like to watch stuff that's put out there by people that are on my level or above my level, if that makes sense. Yeah. Right. Now, as you're going on the basis, I've got my 2 5K pots here ready. I'm going to leave that to last. I've just got to do a couple more tests to work out if they can go in or not, but it looks like they're going to be able to go in. The center tap of it goes to the input of an op amp, so that literally takes nanoamps of current. So I don't see why a 5K pot is not, it sits across about a volt. Now a volt across 5K, it's going to be down there. Let's get a calculator and work this out. So current's going to be, say, why am I trying to work it backwards? Voltage, 1 volt, what, a 5K pot, yeah, 5K pot. That's already 200 microamps. Yeah, so unless that pot somehow ties into the constant voltage circuitry, and changing the value of it then messes up that, there's no reason why I can't put a 5K pot in there. Either the 500 ohm pots are put in there because the older op amps that were in there had a slightly higher input current, but still not that high, or the person that's been doing work on this over the years just put them in there. Which I've got a funny feeling it's that more than anything. I think because, like the voltage pot was replaced with a 20K, not a 10K. I get the feeling they were working with what they had lying around. and because it's only got a volt across each end, not the wiper, I mean like the each end of the pot, they probably were like 500 ohms a volt. That's all right. It's not going to draw too much current. That's all they had lying around, so they used it. I could be wrong. I'm just taking a guess, but yeah. So we're gonna do that. I'm gonna take these 4.8, should I say 4.7k resistors out now. I might hold the board sideways, just make it a bit easier for me. Well, that's one half of the 4.7k resistors desoldered. Let's do the other half. So, all the resistors can come out. Don't worry guys, I know where they all go. I've been staring at these boards for that long, I think I could draw a pretty accurate picture of them. Right, 8 resistors. First one, I'm going to throw it away. I think I'll solder in one side at a time. It's going to be a bit awkward to hold them all in place and push them through and bend the wires, the leads, and then do that other side without the first side getting pushed out the way, if that makes sense. So I think we'll just do this. Why did I just put that there? Do silly things sometimes, don't I? I just want to get them a little bit neater. That'll do. Soldering iron's gone to sleep, damn it. Oh, I was going to pause. I need to go get something to eat. I'll be back in a sec. Alright, so I just finished soldering these resistors in. I figured no one wants to watch me just do the same thing over and over and over and over again. So I just finished my food and put the other 4 resistors in. So that's that. Actually, there is one other thing that I have to do. These references, those wires are going to snap. Funnily enough, there's not one single strand that's snapped yet. Kind of amazing. I'll leave them for now because there's a chance that I might still end up having to take the board back out again. I probably will, because one thing I forgot to tell you guys is something else I wanted to add to this. High set limits for the current, constant current and constant voltage. So with the constant current, these are the 2 op amps that monitor, measure, should I say, buffer, whatever you want to call it, the voltage across the current shunt resistor. That's the high value resistor. Those are the low value resistors in the voltage divider that's across the shunt resistor. So if I put a trimmer pot across here, basically I can essentially add gain to it. If I put trimmer pot across those resistors, those 2 are in parallel, I can remove gain. So I can fine tune the constant current limit. So I can make it smack bang on 1 amp. And I'm going to do the same thing for the voltage. So it's smack bang on 30 volts. So, yeah. What else? That's all I can think of. Yeah. I don't think I had anything else in plan, really. Just add some trimmers to set the high set point limit, and yeah, what you see that we've already done. So I'll put that board off to the side for now. I guess this is kind of probably a bit silly of me. I should have just done this from the get-go, but yes, I'm going to take these out. I'm going to go in with the 10 watt resistors. Like I said, I loaded it up with an amp. I don't know what I was thinking. I mean, like, even running an amp through a 0.47 ohm resistor, it's going to get warm. So 1 ohm, yeah, definitely go as big as I can go. It just makes sense. So I'm just going to work out how I'm going to mount these. I know I want to tuck the legs in as much as I can. Like that. Oh no. Get out there. These cats, I tell you. I hate working in here with the door shut. Like, I don't know. I'm just one of those people that hates being in a room with the door shut. And, yeah, they make me do that a lot. Yeah, that'll work. It doesn't matter if it touches that. I won't let it short to that. I'll put it further down this way than that, because all these 4 pieces are all the one connection. So you can't short anything there. You can only short that to that. Yeah. Yeah, so that's what I'll do. It's also offset to the side a bit anyway, so it'd be pretty hard to screw it up. Oh my god, this cat's up here again. Why are you doing this to me? You're not... Come on, man. Please. Right. Still gonna make one more up. Alright. I'll just tin those legs up so I can float them straight into those holes. Or should I say slots? That works out quite nicely. I couldn't be happier. What a result. Alright. It even looks neat. Just making sure that there's plenty of solder holding it down. Alright, let's do the other one. You beauty. Alright. Little bit of extra leg on this one to trim. That's that. So the current shunts, they're just resistors really, are now 10 watts. So way better for thermal drift and accuracy. They can go back in my drawer. So all we got left to do now is 2 base resistors and 2 pots. I kid you not. That is it. I'm just tossing up in my mind whether I want to do it now. It's getting late. I might go to bed and do it tomorrow. I'll still make all one video, but I'm gonna make a drink, get a cup of coffee, and if I feel like doing it, then I'll do it. Otherwise, I'll do it tomorrow. So I'll be back soon, guys. You guys won't. When I say I'll be back soon, all I mean is I'm hitting pause or stop, and you know, I splice my videos together. So for you, it's soon. For me, it could be any amount of time. But I'll see you soon.